All right, you can just get into a question then. Let me know if you've seen this before, but okay, you can see me typing, right?
Yeah, I can see
Okay.
the cursor.
You want to change it to your language of choice?
Yeah, I'll be using Python.
Okay, cool. Sounds good. Okay, so here's the question. Oh wait, whoops, sorry. Okay, we're gonna do the word break problem. Have you heard of that one before?
Yeah, that definitely sounds familiar, but I guess seeing it, I'll know.
Okay, cool. So, okay,
Yeah, I've definitely done this problem before. So I guess just to give an overview of the solution approach, basically what I could do is this ends up being a dynamic programming problem where at each, say, solution index, I would store whether I can, break to that point. And what I'd want to do is move forward, starting from the, first index and move forward to check if there's a previous section at which I can break a word. And from all the previous sections where I can break a word, if, the substring from that portion can also form a word in the dictionary, then at the current index I'm checking, I can also, break into separate words. And in the end, I just return whether at the last index I can, break the words.
Okay, sure. Okay, given that you've seen this problem, would you want to do a different one, or would you want to just go through it?
I guess I can code this out because it's DP, and I guess those ends up being usually pretty short, right?
Okay, sure. And then we can go through maybe the process of testing it also and coming up with some examples.
Sure. So just to talk about the complexity of this, it ends up being big O of n squared runtime, where n is the length of the input string, and it's big O of n space. So we can break on S. What we have is solutions equals false for and we have false for each of the indices in n plus 1. Then we just say that solutions at the 0th index is equal to true, and this is if we actually don't use any items at all, right? So what I want to say, I forgot to include the actual dictionary, or it's called word dict in the actual problem. What I want to say is that for each of the ranges in n, I want to see if including, to that word or to that index from a previous index, it turns out that I actually have a new word. So for end in range, n, for start in range, n minus 1 for the last index, I'm going to say that if I can actually break at that point, I want to check if there's a new word formed. So word is going to end up equaling the s from start to n plus 1, and if word in word dict, well, there's only one case that it actually try to break at all, which is that the solutions at start is true. So if solutions so all this is doing is it's checking that I can start forming a word from this start position.
Okay.
If the word is in word dict, then I would break, and I would also say that solutions at end is equal to true. Cool. I think this ends up being the translation of what I said previously into actual code, but let's just, I guess, go through it, not line by line, but just overview. So I start off with setting an initial solutions array that is n+1 length, because the zeroth, an empty string always has a solution. And then I want to say, including this many characters, can I break, right? So when I say that solutions of 1 is true, it means including one character from S, can I actually break? So I start off and I want to end up including the first character. So my end is set as 0 and this goes until n. And I want to keep going backward from that end position that I have for my start value. So I start at end -1, I go until 0, decrementing every time. If it turns out that I can't start breaking from the start position, then of course I shouldn't be checking if I can form a new word, right? So I'll just continue. Eventually, my start should end up equaling 0. Say my end is value 5. My start will eventually hit 0, so it's going to check if the entire string can form a word. And the substring is, start n+1 because the n+1 portion is exclusive versus the start portion for getting a substring is inclusive. And again, I see if the word is in my word dictionary. I don't really need to assign word. I can just copy this in here because I don't really reuse it. Turns out I can form a word starting from the previous breakpoint to now. That means that my solutions including end characters is true. So yeah, this seems kind of okay for actual overview. The boundary cases that I really care about are my say empty string, which in that case I'm not going to go through my loop, and I'll just have solutions set to solutions of 0 set to true. Can I assume that I will get at minimum an empty string? Like I won't get none, right?
Yes.
Okay. Sure. So this is a very basic example for boundary case. Because I went through the overview of the code before, is it okay if I just use print to print off the answers instead of like going through line by line?
Sure. Yeah, that works.
Okay.
So yeah, maybe just talk about what you expect it to print. Yeah.
Right. So let's say we have apple, and then kind of have nothing as your dictionary. This would obviously end up giving false. Versus if it turns out that your dictionary, or rather your set, let's just say to make it easier, I'm going to make it a list at the input each time. I'm just going to convert apple. This is the case where it turns out that I only have a single word and there's no breaks in the middle. But instead I might decide to have APP and then LE, which would still turn out true. This is an example where it can't break, so it should return false. And then I would, of course, want to have multiple breaks, right? The easiest thing to think of is maybe it's just one character over and over again. And I should be able to reuse this word. Cool. So this is true. This is also true. Oh, and I ended up returning false for everything. So there's definitely a bug, except for the empty case. So right off the bat, I'm pretty sure it's probably a similar thing that's causing a bug for all of these. When I start off and I go through, I have my solutions. Is it actually going to the right index is one question to be asking, and it is not. yeah, the thing that I'm actually returning, that doesn't seem like the right index. So my end range is n, but because that's exclusive, it's only going to go to n-1, right? And I'm confident that I would want to have, you know, a solution that goes to n, but I think that this would actually start from 1 instead. This would go to n plus 1, and I would not include the plus 1 for the bounds of the string that I'm looking at. And that seems to fix it. Let's see, so I have true, false, true. Sorry, I'm going to get rid of the hello world.
Okay, sure.
Yeah, true, false, true, which is correct, and then true again, true, false, true, true. Yeah, so these seem to match out. I think that should cover most of the test cases that we really care about. So given that, I think I'll keep that as my solution.
Okay, awesome. That was pretty fast. I guess since you've seen this before. Okay, honestly, I didn't expect you to get it that fast. So, we could either do a different problem or that's all I have actually. I don't have an extension for this problem.
Yeah. I guess doing a different problem sounds good to me.
Okay, sure. Is there any particular topic you want more practice on?
Not particularly, because usually, you know, anything goes, right?
Yeah, right. Okay. Okay, have you done the spiral matrix problem?
The what problem?
Spiral matrix.
Where you print off a matrix spiraling in. I want to say yes, if that is the problem.
Okay. Okay, I want to try and do one you haven't done before. Let's see. Alright, what about...
Yeah, I want to say I probably haven't done a lot of tree problems, but I guess they're also not that common, right? Compared to just problems on arrays.
True. Okay, I'll give you a problem I've actually gotten in an interview before. Okay, can we just delete this then?
Yeah.
Okay. Okay. So with this problem, it's not necessarily a binary tree. So we have a tree and it can have any number of children. What we want to return is, so let's say we have something that looks like this. So let's say you have 1 at the root, something like 3, or let's use letters actually. So let's say like A, B, C, D, and 2 children, E, F, sorry. Okay, let's just say for now, each of those have 2 children, H, I, J.
Okay.
So these represent the nodes, but these could have their own values. What we want to do is print the nodes by level, but we want to print a dash representing which level that node is on. So what we would want the output of this to be would be a string, and it would be like dash A, and then it would have 2 dashes for each of the nodes in the second level, and then it would have 3 dashes before each of the nodes. Sorry, 3 dashes before each of the nodes in the subsequent.
I see.
Does that make sense?
Okay. Yeah, and you're saying that basically even though there's 3 nodes or 3 children followed by 2 children, it's just n children, right?
Right.
So we can say as an array of children. Sure.
Right.
Yeah, so
So you can define the data structures how you would want also. Yeah.
Okay. So what it seems like I could do going through this is I just want to perform a level by level traversal, right? So
Right.
that ends up being the equivalent of performing BFS. So I'm assuming that for this problem, I'm given the root of the tree. So
Right.
from that, I would want to pretty much just perform BFS starting from that node, except into my queue, instead of just adding the item, I should be able to put the item and its level into the queue.
Mm-hmm.
And from that, I should have the guarantee that as long as I, say, add the children going from the 0th index child to the last index child, I'll have the left to right order, assuming that, that's what signifies the left to right order. And I'll also have it in the correct, level by level traversal, right? Because with the queue, I'm guaranteed that BCD is going to be processed before anything on line 4.
Mm-hmm.
Yeah, so I think if I were to just go through and run that, it should give me the string output that I want. And for the actual runtime complexity of that, it's the same as running BFS, which is, in a sense, it's supposed to be the number of vertices times the number of edges, right? Or plus the number of edges.
Mm-hmm.
Yeah. So is it okay if I code that out?
Yeah, sure. That sounds good.
Okay. So I'll just keep like a small filler for what the tree node is going to be, and I can place it in afterwards.
Sure.
So
Sounds good.
right, let's call this traversal from the root. For the queue, which is going to be just a root at level 1. And we say that while we have our queue, we'd want to keep processing. So we have that the node and level is going to equal the queue.popleft. Held in node.touch. And we would want to just append. So queue.append the child and level +1. That should be all that's required for processing the next level. And all that we should have to do is append to our result on line 23. Cool. In the end, we just join our entire result. think that ends up being the entire translation of what I was saying into code, but I'll go ahead and fill in the tree node implementation and then run through it. So tree node ends up having a value as well as children, right? So self.val is equal to val, self.children is equal to children, except if it's none, that's a separate check. So if children is none, then we say self.children is equal to empty list. Otherwise, it's set to what's given as the argument. So the only reason I have the none instead of just using a empty list as the actual parameter, I remember there's something with Python where the actual empty list is only going to be initialized once, and there's something about when you update it. I guess it's not relevant when it's in a constructor, but the empty list, it's always going to be the same thing that's referred to in the init function instead of some new empty list when you call init another time. Yeah, but I guess to the actual traversal code, reading through it, we end up having our queue with just the root at level 1, as we said we would, and our result is initially an empty string, which we just use as a list because it's easier to append to a list than to concatenate to a string, just because the strings are immutable. So we'd have to, reallocate the entire thing every time. So we have our queue. We say that while it is empty, we're just going to go ahead and get the node and level. For each level we have, we're going to end up just appending a small dash. I'm not entirely sure if that's valid Python syntax to just, multiply and then add a string together like this. But I guess we'll see when we run it.
Sure. I think there's can you run code in the shell on the
well, I mean, I could run it here as well. So let's say I have a tree node, let's just say with B. I'll just do the first level to make it simple.
Okay, sure.
So this is C followed by D. And then all I should have is the children for A is going to be B, C, D. And then I just do a traversal on A.
Okay, sure.
So this seems to work out as intended. Just a small check is, I guess I'd want to just add E and F, just to see that this is, more than just one level. Let's just add this to right B, C, F. Cool. And I guess that for, the remaining items that I have to add in, that's also going to be okay. So I covered the, empty root where on line 24, I just return the empty string in the case that happens, so that I don't try and have none as my node. So given that, I think that'll be my final solution.
Okay, that's awesome. And then, do you want to talk about the runtime complexity?
Yeah, so it ends up being the same as BFS, right? Where it's just big O of V plus big O of E, or big O of V plus E, where V and E are the number of nodes and edges.
Right. And then the space complexity?
Yeah, so for that, it should end up being at max the number of items I have at the lowest level, right? I want to say that if it's a binary tree, which is the worst case I should have, in that case it ends up being log n, right? I don't know if it ends up just being log 3n and log 4n, or variations of that, depending on how many children you have. But I want to say probably.
I see. Okay, cool. Yeah, that was awesome. You got that pretty fast. Yeah, definitely seeing that this is like CSS is a key thing.
I'm sorry.
Yeah, I don't have much more for you. I don't want to spend too much of your time, but that was awesome. I think you covered all the cases. So I can leave you some comments and feedback.
Okay, cool. Yeah, and I guess that ends up being the half an hour, right? As well.
Yeah, yeah. So yeah, getting through 2 questions half an hour is awesome.
Cool. Is it okay if I ask a question as well, or is that?
Oh, sure.
Yeah. So just wondering, are you just doing this in your spare time, or are you also interviewing, or? Yeah.
Yeah, I'm just doing this actually in my spare time. Yeah, to practice. I'm also trying to prep for interviews as well. So.
Gotcha. Cool. I'm guessing, but you're already working like full time as it is.
No, I'm actually a student right now.
Gotcha. Okay.
In my last year, yeah.
Cool. Well, I guess thank you for your time.
Yeah, thanks a lot for your time.
Yep, and good luck with your interviews.
Yeah, best of luck to you too.
Bye.
All right, bye.